first off, Sloan's gonna explain to you, Edward, why your question was silly. Why you can't actually slice something into dodecahedrons,
You can.
because that's a 3D object. I think you meant a dodecagon, and he'll talk you through how to find the area of one of those.
And when you go into the fourth dimension, don't do it, man.
It's
Don't
crazy,
do it.
man. Turn back. Turn back.
Divide by 0.
Okay, first one we're gonna talk about today, the disk method. And I'm gonna try over here just to keep our formulas straight. We have done cross-sectionals, and all of these are technically cross-sections, they're just different versions of cross-sections, how to slice them differently and how to create the shapes. This is the old one where A of X, or A of Y, or A of whatever, represents the area of one slice. We'll use that to springboard into the disk method. And if we have time today, which we probably will, we'll move into the washer method, which is disk method 2.0. So, let's start with one of my faves. Okay, here's what you're going to do. They're going to give you an area again, like they did here, but that area is not going to serve as the base of our solid. That's going to serve as a template for creating our solid. So here's the area for our first example. Let's take the region trapped by y equals square root of x, y equals 0, and x equals 4. Okay?
Okay.
So that's going to represent the area in the same way that it did in this problem. Can you visualize that? Can y'all picture that particular area? It's not a difficult one. A crude sketch. I'm trying not to be too terribly bad at this. Alright, so square root of x is going to look something like this.
Always pretty.
Okay. Starts there at 0, 0, curves up, top half of a parabola. Y equals 0 will be this one, the x-axis itself. And x equal 4, I'll go ahead and just chop that off right here. It's a vertical line out at 4.
It's a nice cut.
Okay, so the area in question would be this zone right here. Now, before, we would take that, lay it on the ground to serve as a base, and then we would build our structure coming up out of that base. And so we'd have tiny pieces down here, bigger pieces down here to create this growing wave of something, whatever it is. Here's how we change this. Area, good. Now instead of growing out of it, what we're going to do is rotate that area
Over a certain point.
over, not a point, but in this case a line. So we're going to rotate this about or around the x-axis. Okay? And it's a really good habit to get into, to draw this little loop, just to tell you which way you're spinning it, because in the future, meaning at the end of class today or early tomorrow, we could take this thing and we could spin it around the y-axis to create a completely different shape, or we could spin it around like this line down here, or up here, or something else.
Can you spin around just a line?
You can, but not in AB or BC calculus yet. Technically what you would do then is, say I wanted to spin it around like this line.
I want to do it around y equals x minus 4.
Right, okay.
And get that nice.
Yeah. If you were to spin it something like this, okay, theoretically what you would do is rewrite the equation so that it shifted everything to either horizontal or vertical, so you would kind of tilt this and then spin it around one of those axes. Yeah, the shapes today are going to be pretty awesome to visualize. So
Actually, all we had to do is make it so just make it like 2 and do it later. Just make like do like a little point, like 2 and then curve over top of the boundary region.
yeah,
It's
so
the same thing. But
let's try and picture what's actually happening here. Okay. So if I'm taking this area, you know those, I don't know if it was your class or the other class, I think it was the other class. You know those crepe paper party balls? You unfold them and make a big ball and you hang them up, and you know what I'm talking about? That's kind of what we're doing here. We take, it's flat to start with and we're just unwrapping it to create this 3D shape. Yeah, crepe paper kind of ball thing. So when this thing spins around the x-axis, it's gonna create a solid that will look something, okay, like that. And, okay, so picture this spun around to give a little 3D-ness. Okay.
So really, we're just doing, no, we're not, never mind.
Go ahead. So the shape itself looks like
We're doing,
that.
so we're really just doing circles?
There it is. So when we talk about what the slice, if you were to cut this at any given place, what the slice looks like, it's a circle. And it will be a circle today, tomorrow, whatever. Anytime you do, it's what's called the disc method, because it looks like a disc, okay? Every slice is going to be a circle. Any random cut, if we stop
This is
it.
just, what's it called? This is just like a point, it's the same thing as having the, other method.
It is exactly the same as cross-sections,
Yeah.
cross-sectional.
We're just always using circles.
Every single slice is gonna be a circle, and it's that way because of how we created the object. Instead of building it up, we spun something to give us the shape of a circle every time. Does that visually make sense to you all, what just happened? Okay, so, I guess the question then is, if the slice is a circle, what's the area of a circle? Pi r squared, okay? So it's nice to know that the area of a circle is just going to be pi r squared.
1/2 d or squared.
So in theory, our volume is going to, and I'm gonna go ahead and pull the pi out front because it's just a constant. Pi from A to B of r squared dx, where r is the radius. Now, in this particular picture, the radius changes. So the closer I am down here, it's got a teeny tiny radius. Over here, it's got a much longer radius, but what defines the radius is the same throughout. What defines the radius of a given slice?
That function.
In this case, it is wherever the function told us to stop.
So
So
y.
So in this case, the y value or the f of x value, typically written like that.
Yeah.
Okay? Now, I will caution you, for disk, that's a decent formula, okay? To think of it as, you could even write pi f of x squared. For washer, the updated version of it, you're really gonna wanna think of it as radius, because it gets a little bit harder to calculate if you just stick with f of x or g of x. The radius is not always the function value. But, there's disk. So for us in this example, the volume is going to be pi antiderivative
Of the square root of r squared.
that's square root of x, which is our f, squared dx. Pi r squared. Two of the most common mistakes that kids make, and every single one of you will make this mistake at least once, just get it out of your system before the AP test. Number one, forgetting the pi. It will happen, don't let it be you. Number two, forgetting the square. It will happen, don't let it be you, okay? Missing one other thing in that starting point, stopping point.
0, 4.
0 to 4, problem.
Oh, she's here. I didn't know she was at
We have, are you just sitting there to be comfy? Because we have chairs. We good?
Nice compliment.
I didn't realize she had moved the chair over out of the way, and I didn't know if you just ostracize yourself because you got a chair back there, or if it's more comfy. We should get recliners for everybody.
It is actually really comfortable.
0 to 4,
Can we get vibrate chairs?
that would be nice. Yeah, look at that.
Massagers.
Yeah.
I feel like it's important.
Yeah.
After
We
this,
just get some AP money, yeah, to write that together. I need 5 reclining, vibrating massage chairs. If you don't
they're
mind.
like, why? It's calculus.
Calculus.
You know, it's fun, probably should record this. When I was we got a hard drive for the videos for Fourth Block. And Mr. Parker said it would probably be like $90 for a 2 terabyte hard drive. So I emailed the district office and said, we need a 2 terabyte hard drive for $90, and they interpreted that as 2 $90 hard drives. So they sent over $200. And I emailed back and I was like, okay, thanks, but a single 2 terabyte hard drive was only $90. And I can find some way to make the other, I just need to cleverly word how I'm gonna use the other money. We could have a really big pizza party, but I don't know how I'm gonna write that off. And then the DO sent back, my contact up there said, yeah, pizza parties are always listed as student incentive. So I was like, sweet, I can do that, yeah. Yeah, I was like, I can do that, yeah, right, student incentive, yeah.
No, it's more like after the pain of calculus, you have to.
So do you pretty much
relax.
get what you want or something?
I asked for like one thing a year, and
That's like-
I think all I asked for last year was practice books for y'all. That's it.
Yeah, yes, guys, for like pain medication for Shannon.
Yeah, right, yeah, we need a bottle of Advil percentage, yeah, a couple of bottles of Advil, some stock in Advil. All right, let's finish this one up. If I stick this on a piece of paper and I say go with it, what would you do next?
You suck.
Take it in.
I'm sorry, what? You some? Seriously?
Why not?
What would you let you be?
Square root of X.
Okay. What's wrong with Michael's idea for
Why?
acidic?
Cause why not?
Okay, u is the root of x. Don't write this down. What is du?
I don't even want to, I'm not.
It's one. It's
What's
one.
du? Not 1.
No, it's 1 over the square root of X.
Close.
1 over
1/2 x to the
Yeah.
negative 1/2
It's
dx.
1 over 2 square root of X.
There you go. Alright, now, here's the dealio. Here's u.
Why would you do that?
Yeah, I know. Now, I don't have another one of these that actually get gobbled up with the
Dang
dx, so
it.
nice try. I'm just spitballing here.
Why don't you just stop?
Why don't you just take it in?
That's not even that great either. Why don't you just do this? What did the square root?
That's not
square
fair,
root
you
cancel
can't
do?
just solve it, just.
Yeah, just, oh, look at that.
Look,
I'm digging it.
Why?
Seriously? Really? I get it though, you wanna make it challenging, make it worthwhile to do the problem, right?
Yeah, but you're just
Why
like,
not?
Whatever, okay.
all this is just easy. It's easy. Like, I need some.
Okay, hold that thought.
No.
Hold
go,
that
let's
thought.
go.
Top gun, alright,
Yes.
let's just see what you got. Antiderivative of x is 1/2 x squared, the 1/2 is just a constant, so I'm gonna combine it with the pi.
Can we do my next? I really want to do this one. It's going to be a cool shape.
Okay, hold on.
Stop getting so
Yeah,
excited.
just wait a second.
No.
Okay, let me plug in 4. 4 is gonna be 16, and 0 is going to be 0, for a grand total of 8 pi. 8 pi. So the volume of that object, whatever that object is 8 pi. Out of curiosity, because they don't really ask this, but it's kind of, for those of you having trouble visualizing it, what shape are we creating? Give me a representation of what this object might be.
A dome,
Like,
but like not like a circular dome.
I like that, turn your head sideways, yeah. Does that look like any object in real life to you?
Kind of, if I picture more, it kind of looks like one of those old-fashioned car lights.
A floodlight kind of thing?
Football.
Football? Well, the problem with the we'll
It
do a
looks
football in a
close.
second. The problem with a football is that It's just
Curve.
getting like bigger here. If we had the other half of it maybe for football,
It's a half.
I always picture like a bullet.
That's what I
Tip
was
end of a
thinking,
bullet.
like,
One of the kids at Green Sea said a ham. He was
was
hungry,
hungry.
yeah. It looks like a ham to him, or what? The kind of bone-in ham.
I was thinking.
You talk
they
about
should like
us.
a sideways
That
heel,
is,
so, you
yeah.
know, I was
Talk about
like,
both of them. Like, let me tell you what the idiots over at 88.
Oh, what'd you
did
say
today.
about me?
I don't mention specifics.
And he's like, that
Shannon,
genius.
Shannon automatically goes,
Gord
oh, what'd
keeps
you say about
wondering
me?
why.
I sent his friend request.
I know.
He's like, he's not helping pass it.
He hasn't
I
messaged
know,
me.
I was like, you gotta actually talk to him.
He's like, yo, just being my friend on Facebook makes me smarter. It has to.
And honestly, it's the other way around. He takes tests like 2 hours before you take tests, so honestly, he would be the one helping you out if it came to that.
I think he just won't tell. Like, oh,
Y'all do, however, have the same quest, so I'm wondering why he hasn't asked you, like, how'd you do the quest questions, so.
Still haven't done them yet.
Yeah,
I'm doing it tonight.
yeah. Oh, I need to give you back your quest too, we'll do that. But yeah, we need to talk about the quest, because I'm not thrilled at all with where we are with our quests. All right, so there's our first one. Again, think cross sections, but every single cross section is a circle, so that's why it's pi r squared. All right, we're good? Let's try another, clearing the slate. Everybody good?
Mhm.
Good. Okay, let's keep this one around the x-axis. For now. Excuse me, for now. All right, how about y is equal to, oopsie, sine x
Ooh.
on the interval from 0 to pi and y equals 0. Okay, now I will say this,
So the one full rotation of the.
one, not
Yeah,
a
hump,
full rotation,
hump,
but
just
one
a hump.
hump, yeah. And the reason they have to be very specific on this is because it does infinitely go like this, and if you think of all those humps being spun around, you technically get infinite volume, so it's,
So cool.
it would create, honestly, and if you took the upper humps and the lower humps and spun them, they would still create the same shape, so it would look like a bead,
Yeah, that's
a
what I'm
necklace
saying.
bead kind of thing. But there's the actual picture, so they do limit it, or they'll give you some other restriction on,
Like an X.
especially with trigs, they have to kind of cut that down because they do
Really,
repeat.
this is just saying from your, like, here's
Your first hump.
your
Yeah.
2X parts.
Right, this, and they could say the vertical line's x equals 0 and x equals pi, but it, and that is technically true,
It's the same thing.
but, yeah.
Well, I guess not, because you'd still have a bunch of unbounded stuff, no matter what you do.
Well, you'd only have one bounded region though, if you went, here's what it looks like, so you got the one hump of pi, or of sine, and it does continue that way and that way. And yeah, we could technically put a vertical line here and a vertical line here, just to say here. But yeah, it would, the boundedness is not defined that well. So here's 0, here's pi, we're doing one hump, and we're going around the x-axis.
Pretty.
Next example, we'll start looking at what happens if we go around the y-axis.
Ooh.
Same kind of shape, it's not that bad.
Just, I'm guessing you use your Y as your.
Right, you do everything in y values. Where it gets really interesting is if you wanted to take something like this and go around the y-axis to create like a jello mold.
Yeah.
That would look kinda cool. Problem with that is the missing space, which is where the washer method comes into play, if you have something missing from the inside.
Okay.
Okay, so this shape, if we were to rotate it, that's the area. So if we were to take this zone right here and spin it around that, we get, here's your football, Chelsea, looks more like that, okay? Like that, and then we do, just at any given slice, you have a circular zone like that. And it's a little difficult to create the 3D shape of this accurately, but I think y'all get the idea. Okay.
So, volume is V equals pi antiderivative of sine x squared dx.
The way you, I think I know what
Sine
you
x
meant is,
squared.
right, yeah. Because if you say, there's a difference between sine x
X
squared
squared,
and
sine-
sine x squared.
Yeah, I want sine x.
Honestly, to keep it from being vague, here's what you do.
Parentheses.
Well, you could do that, don't forget your pi. 0 to pi.
Put your thing in first.
This is saying clearly I'm squaring sine, not squaring the x value. Or put parentheses or brackets around the whole thing and go from there. Pi r squared.
So would you
Get
say
that?
sine squared of x?
Sine squared of x, yeah. That is what most math people
We'll say.
will say, because it's not vague.
You know, I think I got this.
We'll just.
The revolutions, this one? Cool.
Yeah, I think I actually get this one.
Very nice. Okay, so the setup again, it's just a circle, so remember our formula is just a circle, which means you gotta remember the pi and you gotta remember the square. Fair warning for the second of 1,000 times. Okay, let's rock and roll.
I was going to offer you an M&M, but they have a smaller one.
I'm good. I think so. All right,
Ooh.
action.
Antiderivative.
Good. It's a cop out, so what is the antiderivative?
Oh, there's a change.
I don't know.
Wait, no. I don't know, wait, what? This is weird.
Here's the
I'm
problem
so
with using,
lost.
here's the problem with using the chain rule. Chaining is when you take a
Derivative,
derivative
you gotta
of
do
an
something else.
antiderivative.
I'm lost
use.
again.
Okay, let's
You
think
gotta-
U sub. Yeah, that's,
So,
if this is not on my short
It's not
list,
clear.
if this is not on my short list, I'm thinking U sub. And my short list is polynomials, basic trig, e to the x, 1 over x, or the arc trig stuff. This is close, minus the
I tried.
squared, it's actually golden, okay?
got
But the fact that that square is there,
I tried.
yeah. So U sub. What would U be?
Sine.
Okay, if U is sine, tell me what the problem's going to be.
Problem is you don't have
Okay, so let's let U be sine. Check, call that U squared.
when you take a derivative.
When you take a derivative, you get a cosine, and we don't have a cosine to be knocked out.
I like plugging my calculator.
Option 1, plug it into the calculator, yes. Now, if this were a calculator question, I would stop right here, plug it in, beep boop, done.
It's not
Okay.
this guy.
Which you will practice. Some of these on the AP test, it really is, this right here will be worth 2 points. 1, 2, and then your third point would be whatever your answer is from the calculator. So they do expect you to know how to use a calculator.
Oh, okay.
And on your request, the ones I've given you, I think both of those are from the calculator section, so yeah. Okay,
Yeah,
give me,
can I borrow a calculator?
you have it in class today, you can
Oh,
work
yeah.
on your quest if you need to.
That's a good idea.
Alright, so I'm gonna say option 1 would be from the calculator, whatever you get. Okay, actually, let's do this. And I guess some kind of decimal, I'll let you figure that out. I think this one actually turns out to be something like, not quite 5.
Is that the way I do it?
Yes, kind of. Now, there is a BC topic called trigonometric substitutions, where, and it's not really for this kind of problem, it's honestly for other stuff like polynomials that you want to turn into trig so that you can use one of your basic trig facts.
You can do it the opposite, you can reverse it around to make it into a polynomial.
No, you can't do that. This one is more of a trig identity, so for those of you that have pre-cal or like an intense unit on trigonometry,
Sine plus 1? Or the minus 1? I'm just trying to figure out why.
well, okay, here's what the kids at Green Sea tried.
Yeah, plus equals 1.
The
So they-
problem is you get sine squared of x is equal to 1 minus cosine squared of x. The 1 is not the issue, but you've now swapped out a sine squared for cosine squared, and
And now you
it's
have
still the
a
same problem. But there is a substitution that you could use.
4.93.
Right, yeah, good, yeah, 4935.
4.935.
Yeah, so 4.935 is what we're shooting for with a calculator.
Makes sense because of a unit, and then you pretty much times it.
Volume wise, you know, my gut's feeling, yeah, it's a good number, why not, okay. So while this is one of our Pythagorean triples, a squared plus b squared equals c squared, okay, this is a Pythagorean triple. It didn't help us because it didn't get rid of the square. So we're gonna use another one called a power reducer, this one. Sine squared is equal to 1 minus cosine of 2x over 2. Here's the thing, they don't exactly, on the AB especially, expect you to remember that. All right, and I don't even know when you took pre-cal or took algebra 3 or whatever you took, that y'all even, if you had a unit on identities, and I think y'all probably did, like prove that this side equals this side kind of thing, and you had to use all your identities.
I remember.
You may have used
that.
this at somewhere, okay, but it's not one of those they probably have you
Actually,
memorize.
for
I
the-
think it
You
was
teach
my,
it in your algebra 3.
In algebra 3 we will, in
I
our
think my
third
algebra
unit,
2
yeah.
class, something taught, or my pre-calc taught.
I
Probably
just remember,
pre-cal,
like,
in
the
algebra
sine
2, we usually don't
squared
have enough time to
was-
get to this, even in the honors, but pre-cal, you definitely would have done a unit on trig substitution.
I don't know, probably was my, I kinda made her work fast.
I remember the
because
top one.
She either worked factor.
Yeah, this
that's
one's
where I fell
easy,
asleep.
this one you learn in basic trig, that one's, makes a lot of sense.
Oh.
Okay, so here's what we can do, if we have to do it by hand. Disclaimer, on the AP test, you'll probably not have to do that. This would be a calculator question, but for the sake of funds and practice, okay? All right, so I would rewrite this as 0 to pi of 1 minus cosine of 2x. And I'm doing this for a reason, I want to illustrate something in the antiderivative. Okay, this 2, by the way, you can do this any way you want to from here on. Here's what I suggest is the easiest. This 2, think of it like a 1/2, and then yank it out front. So pi over 2, 0 to pi of 1 minus cosine 2x.
And that's no, and then you can just do a U sub.
That's a U sub, but here's what I really want to show you. Yes, that's U sub, but that's a U sub you should be able to do in your head in absolutely no time.
1/2.
That just means you're gonna have a 1/2 in front. And on the AP test, please do not write U equals 2x, du equals 2dx, 1/2 du equals dx. They don't count off for that, but if I see it on one of your tests, I'm gonna put a frowny face. A frowny face. Doesn't count off points, but it makes me hate you more. Antiderivative of 1 is x. What is the antiderivative of this gonna be?
That sign,
Good.
so.
And we just did U sub in our head. Understand that the antiderivative of negative cosine is negative sine. The derivative of negative cosine would have been positive sine. Don't get those mixed up on the AP, okay? We're evaluating that from 0 to pi. Okay. Excuse me, pi 2's. Let's stick in pi. All right, we're gonna get pi here. The sine of 2 pi is 0, so this whole part gets knocked out. When we stick in 0, we get 0 here, and the sine of 0 is still 0. Again, I caution you with your trig, make sure you plug in 0, because it's not always going to be 0. Okay, be careful with that. So we get a whole bunch of zeros, that's just pi, so pi squared over 2. And that kind of makes sense because pi is a little bit more than 3, pi squared is a little bit more than 9, and divided by 2, yeah, we're just shy of the 10 mark here. When you divide it by 2, you get something just shy of 5, so it makes sense. It makes sense. That's if you had to do it the long way, and it's just me being irritating for you. For me, it's fun. This would be a calculator question, honestly, but that's nice.
That's
Why
pretty
not?
much so.
Yeah, it's cute. But it did illustrate that U sub should not be taxing. And when I say that a good 90 to 95% of the integrals you will do on the test are U sub, I mean, almost every single antiderivative will be a U sub in some fashion. That's kind of what I'm talking about. That's a U sub,
That's
but you'll see it all over the place, okay? It's just
on
to,
1/2.
just to see if you're paying attention to your constants. Okay, so, how do we feel with this one? Decent?
I wanna do wash.
Okay. Give it time.
Well, cause the one I wanna do is, it has to be washer, cause
Just chill out, man, we're getting there.
I'm good.
Okay, let's see. All right. Next exciting example. All right, we're gonna take y equals x cubed, x equals 0, and y equals 8, and we're gonna spin that bad boy around the y-axis. Okay? If it helps, draw the picture. But I think if you go back and look at your quest questions, they do a really good job of drawing the pictures for you. All the graphs are typically done, and they don't want you to have to struggle over the visual. It's, what do I do with it now? All right, let's see. Okay, picture-wise, here's what we got going on. Okay, y equals x cubed is gonna look something like this. Okay. X equals 0 is this one, right here. And y equals 8 would be somewhere up here. And I'm spinning this around the y-axis. Okay, so here's my area, and I'm going that way. Still the exact same setup. My volume is going to be pi r, whatever that happens to be, squared. Whatever that is, okay? You have to visualize it sideways, though. Actually, I think this one works out better, the radius. My radius is not gonna be going like this, my radius is gonna be going like this, okay? So I'm spinning it this way to create this bowl shape.
So really, it's the cube root of y.
Good, so when I do it with y, I need to turn everything into y values. So I'm thinking u
That's when you think about it, really, that's all it is.
should be the cube root of y. And honestly, there's your radius, whatever the cube root of y happens to be. So, cube root of y, and we'll do dy. All right, what's my interval?